Welcome everyone. Very good afternoon. We are in the week 9 of this coursework, which named is Geotechnical Engineering 2. Till now, we have studied the many aspects of the practical implementation of the thing which we have earlier studied during our coursework, maybe Geotechnical Engineering 1 or the soil mechanics. Whatever the subject name you have read, the contents are same in which we have understood the basic concepts in the present study, in the present classes, what we are going through from the week 1 to we are currently in the week 9, we are studying what are the practical implementation of that. Okay, before starting that, first of all, I am Sumit Kumar. I am a PhD research scholar at IIT ISM Dhanbad. This is an NPTEL coursework in which we are studying the geotechnical engineering too. We have understood the various aspects of it. This course is taught by Professor DN Singh sir from IIT Bombay. I am taking this coursework in which we are discussing the problems related to the concepts which are discussed in the class. We have currently studying the specifically active earth pressure, passive earth pressure, basically earth pressure theory, and we are discussing the problem related to the same. As we go ahead, we will see some more problem in the today class. Apart from that, this seed pile wall concepts is also I'm going to take on during this class. And maybe some concepts may left out in this class could be carried in the next class, but we will see. Okay, so before starting the thing, I want to draw your attention that some of the important instructions for this class, like this class is going to take place for 2 hours from 3 to 5, as it this coursework is going from last 8 weeks in the same time frame, so it will continue to do so till the end. This is the 12-week coursework. We are in the ninth week, and as I have planned, it may be possible I can take one additional class in which I try to divide the entire things in a very quick manner. So we will discuss in the 12th class. Okay, so I think so. I am clearly audible and visible. If due to any reason internet connection goes down and I am get disconnected, so please we remain in the meeting. We will rejoin and take the class from there on. And that's are the things. And the content which we are discussing, like this PowerPoint presentations, will be shared with you through the Google Drive link, which is already shared with you. Apart from that, in addition to that, the things which we are I am stating for the next 2 hours is also get recorded and get uploaded on the YouTube and will be shared with you by the NPTEL team. So I think so the more or less these much instruction are there. So please be patient, and if any problem or confusion are there, you can ask me at any point of time. And one very important aspect that those who are watching later on the YouTube, you can also ask the problem in the next class or maybe on the forums, whichever the feasible for you. I will try to answer them out as per my capability. Okay, so now we can start the today coursework as we are reading the earth pressure theory. So what are the things? So first of all, we start with the sum of the problems. And as we have discussed the concept in the previous class and also see some of the basic problems, today we will take some advanced problem related to the same, as some problems we have discussed in the previous class in very quick manner due to the time constant. So we will elaborate those problems in this class and then carry forward to the seed pile walls, that what are the things, what are the advantages, disadvantages associated with them. As we move ahead, we will see that some new concept and the problem related to the same. But first of all, we start with the problem which we left out during the previous class, as the time as shortened for us, whatever the problem we have taken on that class. So we will start and with the problems first of all, then carry forward our concepts. Okay, so, as we have understood the Earth pressure theory, we have understood the three types of pressure. First of condition is Earth pressure at rest condition, when there is no pressure is applied by the soil on the wall. And the second, we have understood the active Earth pressure condition, and third is the passive Earth pressure condition. As you have remembered, in the active state, we have understood that the wall is moving away from the backfill, and in the passive, the wall is moving toward the backfill, which we have discussed in the previous class in very detail. As well have we have also understood earlier this theory discussed for the cohesionless soil later on the bell. has added this for the cohesive soil, and we also understood some of the important aspects of the tension cracker, that how tension crack develop. If tension crack is not there, what are the difference in the what are the difference in the value of the stresses. We also come to know that how much the total stress could be acting on on that wall through the backfill. In the active and passive as well as condition, we also understood the unsupported length in the same time. So we will go across one by one, and we will see the problem related to the same. First of all, I am starting with some of the theoretical concepts, then we will carry the numerical problem which we left out during the previous class. Okay, see. So the first problem over here is that what are the main function of retaining wall? So as you know, okay, these are the MCQ. I will read the options, and then I will state the solution and give the description for the same. Okay. So the main function of retaining wall, the option A to support the vertical slope, option B to prevent the soil erosion, option C to provide the drainage, and option D is all of above. As you can easily say that the all the options provided over here is the correct, as we provide the retaining wall, it support the vertical slope. It also prevent the erosion of the soil from that section. It also provide a type of drainage through it, so that due to increase of the water level, the effective stress, due to the increase of water level, effective stress get reduced. So such condition could not be generated, because if such condition get generated, we have understood that earlier we are using the total stress concept. Later on, we have understood that the water is the biggest problem for the soil. If the water table is not there, the soil many more problems associated with soil get eliminated. So we also saw in saying soil mechanics in general that the water is the biggest enemy of the soil. As a geotechnical engineer, we have the several aspects of the discussion regarding these points at the many point of. Okay, so over here, the retaining wall act as a support to the vertical slope, prevent soil erosion, provide drainage. All the options are the correct, which are given over here. Right. Now we will, okay, the description is also there. Okay, so I will read that the retaining wall are used to support the vertical slope, prevent soil erosion, and provide drainage. They also used to create traces, level out uneven ground, and create the raised beds for the gardening, etc. Okay, you have seen that some retaining walls could also be constructed for the spaceway over there to support the soil in between. Over there, you have seen that in mid between some section are there over the trees or plants are get placed out. So those examples they are discussing, and the description discussed about. Okay, so now we are moving to the next problem. Next problem is that which of the following is the most common type of retaining wall? Gravity retaining wall, cantilever retaining wall, buttress retaining wall, seat pile retaining wall. Yeah, over here, the question are most common type. So you know that the most common type of retaining wall is the gravity retaining wall, which is in general because it's self-supported. There is no extra section is needed to support it. So the gravity retaining wall is the most common type of retaining wall, as they are simple to design and build, and they made of the heavy materials such as the concrete or stone, and rely on their own weight to resist the lateral pressure of the retained soil mass. Okay. See, now we have our next problem. What are the main function of the retaining wall? So option is to support the vertical slope. Okay, this is the same problem which we have already solved. So the option number D is the correct answer. We are moving to the next step. Which of the following is the most common type of retaining wall? Okay, some question get repeated in my presentation. I will remove these when I will share this presentation with you. Okay, that's not the problem. Which of the following material is the most commonly used to build a retaining wall? Concrete, stone, wood. But over here, we know that for the retaining wall, we can use all of them for the different aspects where we are creating them. Okay. Now the question is that the purpose. of the weak force in the retaining wall to provide the drainage, to relieve the hydrostatic pressure, to prevent soil erosion. So the drainage is the one of the aspect that we want that water should flow out from there, and it is also that due to that the hydrostatic pressure get also released. So the and it also prevent the soil erosion in a way as the water flow out, because with the if the drainage is not there, the soil also flow out due to the hydrostatic pressure. So it also prevent the soil erosion in a way. So the all the option given above is the correct answer for the given problem. Okay. Now the next problem that okay, the geogrid concepts are there. Okay, that is not very relevant, but we'll take this question as well. But what is the purpose of the geogrid behind the retaining wall? To reinforce the backfill, soil, to prevent the soil erosion, to improve the drainage, or all the above. As you understood that the answer is the option D, because it fulfill all the aspects, because the geogrid also act as a reinforcement to the backfill. It also prevent the erosion and improve the drainage facility. So the option D is the correct answer. Now the question over here, that what is the most common cause of retaining wall failure? Okay, so options are improper drainage, excuse me, or inadequate foundation depth, or overloading, or all the above. So we know that the failure could be takes place due to drainage problem. If the foundation depth is not appropriate, it could also lead to the failure, and the overloading is also one of the aspects. So all the above option is the correct answer. Over here, whatever the option I put out is not for to answer in that manner. The question could be framed if the MCQ could be given in your assignment or any place other. So I will try to frame the question in the same manner. As for this course, the previous assignment question is not with me, so I try to make the question by myself. As you, if you have gone across the previous lecture, I have solved the various very standard questions. Specifically those are asked in the GATE examination or the engineering services examination. Those questions we have discussed in the last class. Today also, with some of the problem which we left behind, we will discussing in this class as well. So I try to make those questions because I don't have the access of the previous assignment which I could solve during the class. That's why I have to take these questions. If what type of assignment problem are there with you, you can, if you want those type of problems, so you can share those questions with me, as I have already given an email address during a class, and you can share on that. If anyone interested to share those questions, I may add my email ID in the chat box. You can send me the question. I will try to make the similar question, but as per my knowledge, this type of question could be asked in your assignment. That's why I'm trying to give some numerical problems, some MCQ problems which could help you. And the long type numerical problems are the those problems which must be asked during the exam certification examination when we go across. Okay, so this question is already we have taken. Okay, so the questions are question is that how can a retaining wall failure be prevented? Again, the proper design and engineering is the one of the aspects. Basically, if we design properly, the drainage condition would be there. If we design properly, the foundation is adequate to sustain that load. If we design properly, what amount of load should be applied, we know that. So the overloading is also not there. So the proper design and engineering is the one of the aspect that will certainly help the retaining wall to prevent from failure. Second is the use of the high quality material. Yes, material aspects is the one of the biggest problem whenever we have doing any construction work in the building material. When you have go across the basic study in the starting before RCC, before steel structure, we have a study about the building material over where the quality control concepts is the one of the most important aspects which are taken into account during the discussion, that how the quality of material is very important before going into the deeper aspects of their application in the field in one way or the other. Third is the proper installation. Specifically, the design and engineering is okay. So designers are doing their work at their workplace. The field engineers who are implementing those design in the field also need to be that much aware to implement those things in the field, that there is a whatever the designer have provided with the calculation and designing aspects from the Indian standard codes, they will implement in the field as well in the similar manner. So the, all the above option are the correct answer for the retaining wall failure prevention. The all things need to be mentioned. If all aspects get implemented, the failure due to any of the reason like maybe drainage, overloading, or maybe in some other aspects, the failure could not be possible over there. Okay. Now the question is that what is the difference between the gravity retaining wall and a cantilever retaining wall? Okay. So we know that the four type the gravity retaining walls and the cantilever retaining walls are the some of the common type of retaining walls. So the options are the gravity retaining wall relies on their own weights to resist the lateral pressure, while a cantilever retaining wall relies on its bending strength. The second option is the gravity retaining wall is typically used for the lower heights, while the cantilever retaining wall typically used for the higher heights. Okay, so over here also more than one option could also be correct. As you know that a retaining wall relies on its own weight is exactly correct. And the second cantilever retaining wall relies on bending strength as per I recall. This is also the correct thing. The second option said that the gravity retaining wall is typically used for the lower heights, while the cantilever retaining wall typically used for the higher heights. I think so. This is also correct. Thirdly, a gravity retaining wall is typically made of concrete or stone, while the cantilever retaining wall typically made of reinforced concrete. So the option number D is going to be correct answer, because all the aspects discussed about the gravity retaining wall and the cantilever retaining wall is correct. So you can get the 3 points about the gravity and cantilever retaining walls from here. Now we have a next problem about the difference between the buttress retaining wall and the seat pile retaining wall. So the buttress retaining wall has a vertical buttress that support the wall, while the seat pile retaining wall is made up of interlocked metal sheets. Okay, that's I think so correct. A buttress retaining wall is typically used for the higher height, while the seat pile wall retaining wall typically used for the lower height. Okay, a buttress retaining wall is typically made of concrete, stone, um, or stone, while the seat pile wall retaining wall is typically made up of metal. So the option number uh, D is going to be our correct answer, because the all the options mentioned over here with is stating the correct answer for our problem. Give me a minute. Okay. Okay, right. Okay, so we are discussing about the difference between the buttress retaining wall and the seat pile retaining wall, and we got that whatever the point discussed over here is the correct answer. So you can, in your notes, you can also mention these things as the 3 points about the buttress and the cantilever, sorry, seat pile retaining wall you have understood. Now we are moving to our next question, which state that, okay, sorry. Option C is not correct in the previous question. A buttress retaining wall is typically made up of concrete or stone. Oh, sorry. This is about the cantilever. Okay. Okay, some repetition takes place in my problem. Okay, give me a minute. This is the point about the cantilever which is mentioned over here with the buttress. Okay, now it is correct. Now you see what are the next question. Uh, Basically, during the preparation of the presentation, I some problem over here of the electricity, so I could not able to make the presentation with the free mind. I have made this in a very small section of time, due to which at some place some repetition takes place as question get repeated. as internet facility is shut down today over here due to some reason. Uh, that's why this presentation I have prepared in very less time. So some repetition, some fault may be there, but not to worry. You can mention over here if some wrong thing is there. I will appreciate that. Thank you, Muskan, for mentioning that. And I will when I give this presentation file in the Google Drive, I will rectify all the errors because I can upload that by in 1 or 2 days. So that's not the problem over here. The whatever the content presentation have, that must be rectified with the error whatever have over here because as I have a very less time in the electricity and internet problem over here for the days. That's why I not got that much time to implement or think whatever I have did in the previous classes. So there must be some error in this presentation, but I will rectify before uploading. So over there you can see that everything will be in the order. Right. Um, what are the factors that should be considered when designing a retaining wall? So, the factors are the height of a wall, type of soil, surcharge load. Yes, we already know that the height of the wall, type of soil, surcharge load, everything need to be taken care of while designing a retaining wall. So the option D is the correct answer. The next problem is that what are the steps involved in construction of a retaining wall? Okay, so this is not the question specifically. This is the thing that we put that the steps involved in construction of retaining wall. First of all, prepare the site, install the foundation, build the wall, backfill, and compact that backfill section. So that is the thing over here. This is not the question. This is the solution in itself. Okay, okay, right. We are going to end this section because I want to carry the thing forward. Okay, so now we're talking about the types. What are the types of maintenance should be performed in a retaining wall? So the inspecting the wall for the cracks and the other damage exactly. Repair any damage that found, that's also the right thing. And if some debris get accumulated at certain sections, could be should be removed. So these are the things which we need to do during the maintenance work when performed for the retaining wall. So the option D over here mentioned is the correct. Now the benefits, because if we are using the retaining wall, there must be some benefits for using that. So what are the benefits associated with you while using the retaining wall? So they provide support to the vertical slope, prevent soil erosion. We have seen this earlier. They provide the drainage as well. We can provide the drainage through them. So we are the benefits which we get. We have already answered this question in the other from format is very first or second problem for this section is this only. Okay. Now we have numerical problem over here. Okay, so I will try to solve it with the pen and the paper as well. But if we could understood from here only, so I will not go for that. Okay, the question is there: a retaining wall 3 meter high retains a soil which has a unit weight of 19 kilonewton per meter cube and angle of internal friction is 30 degree. What is the active pressure on the wall? Okay, so we have already know that 1 by 2 k gamma h square is a formula as well, but I will try to solve it out. Over here, I will draw something. Okay, I need a pen. Okay, over here you see the 3 meter high retaining wall. They are mentioning that this is a 3 meter high, and the unit weight over here is the 19 kilonewton per meter cube. Angle of internal friction is 30 degree. As you see, k is equal to 1 minus sine phi by 1 plus sine phi, coefficient of active earth pressure. So when you calculate this value, we come to know that this value is going to be active earth 1 by 3 for phi equal to 30 degree. For phi equal to 30 degree, 1 minus sine 30 upon 1 plus sine 30. When you do on your calculator, you will get the value as 1 by 3, 1 upon 3. A retaining wall is 3 meter high. So first of all, we make a earth pressure diagram. So as water table is not mentioned over here, so we come to know that this 3 meter height is there, and it is asking about the active earth pressure on the what is the active earth pressure on the wall. Basically, wait, give me a minute. 1 minus sine phi upon 1 plus sine phi k 1 by 2 into k into 1 there is also a error over here. This is as total active earth pressure it is asking 1 by 2 into k into gamma into h square. Okay. Give me a minute. This is asking what is the total. Right. Okay. See, so what is the total active earth pressure acting on the wall? So PA equal to 1 by 2 K gamma H square. As this height is 3, when we find the value over here, we get as K gamma H. K gamma H. As gamma K is already mentioned as 1 minus sine phi by 1 plus sine phi. So what we needed at the area of this section. When we calculate the area of this section, we come to know, I will write over here, as area as 1 by 2 into 3 into 1 by 2 into 3 into K gamma H, right? Right. This 3 is also H, that is one that is what they have written 1 by 2 into gamma. We have gamma into H square into K we have this 3 is also H, so 1 by 2 into gamma into H square into K. Now we have calculated the K. So over here you can see the calculation of P is already calculated. 1 by 2 into gamma is 19 and H the height is 3 which is 3. Over here you can see 3 and over here also you can see H, that 3 into 3 multiplied by coefficient of earth pressure K, that is 1 minus sine phi by 1 plus sine phi. When we do the calculation we come to know the value is 30.43 kilonewton per meter square for the given problem. Okay, I think so things will be clear because we have already solved the very the advanced problem from this thing in the previous class. So this is the very basic problem. I don't think anyone have any problem associated with this. Okay. Now we have a next problem. The next problem asking a seat pile wall 4 meter height retains soil with a unit weight of 20 kilonewton per meter cube and angle of internal friction 35 degree. What is the passive earth pressure on the wall? Okay, so the question is about the only passive earth pressure. There is no other thing is mentioned. So we calculate again in the same manner pp equal to 1 by 2 into 1 by 2 into gamma into h square into kp. As again this is the 4 meter height and the unit weight is 20. So you see our calculation 1 by 2. Okay. And you can see pp equal to 1 by 2 into 20 into h square into 1 plus sine phi upon 1 minus sine phi. So value is going to be 72.11. This is a simple problem. I don't think we need to take more time on this question because we have more complex problem coming ahead. Okay, this is also I think so similar problem. So I will leave it for you. You can solve by yourself. I think so. A retaining wall 2 meter height and retain a soil of unit weight 18 kilonewton per meter cube. Angle of internal friction 25 degree. What is the minimum depth of wall foundation to resist overturning? Okay, so this is again you see. Um, okay, leave it. We have not read this thing. I will not take this question at this point of time because we need a theory of this before discussing this. I will discuss those two problems in the next class because the theory is associated with that we haven't discussed yet in the normal class as well and over here as well. Right? Okay. So we are moving to again the next problem. That is this. Okay. Now you see, as you are seeing over here, the question is asking that the surcharge loading required to be placed on the horizontal backfill of a smooth retaining wall so that completely eliminate the tensile crack. Okay, so this solution, some calculation I have written over there. Just you see, as you know, that the value of when we write the equation for the active work pressure, we write K into gamma z multiplied by minus 2c root K. Or if the surcharge is there, the K into gamma z, you can see the screen on the top right corner. Over here, we have written K into gamma z plus Q minus 2c root K. That is equal to 0. Now the question is asking that the surcharge loading required to be placed on the horizontal backfill of a smooth retaining vertical wall. Okay, give me a minute. I will be back in 1 minute. Give me a minute. Okay. Hello. So the question is saying that how much the surcharge load should be there that it will there be the surcharge loading required to be placed on the horizontal backfill of the smooth retaining wall to completely eliminate the tension crack. Okay, so you know that when we are discussing about the tension crack, okay, you know that there is no pen. This is a specific section, and when we are talking about the tension crack, if there from this equation only, at z equal to 0, when we write this is for PA active earth pressure at a specific section. And if Z equal to 0, the value is going to be K into Q minus 2C root K because as Z equal to 0, as the value of Z equal to 0 and there will be no surcharge, then this value at the top is going to be minus 2C root K minus 2C root K. Okay, okay. So this minus 2c root k plot will be there. So this is asking, as we know that the depth of tension crack is up to this section, that is 2c by gamma root k. We have already discussed as well. So this is asking that how much the value of Q, so that when we draw this pressure diagram, this will be drawn like this for this section as well. So at if at Z equal to 0, when we put Z equal to 0 in this equation becomes K into Q minus 2C root K equal to 0. Then when we solve it we are going to get Q equal to 2C upon root K. So this is our answer that this much amount of surcharge if we apply, then the chance of development of the tension crack get eliminated. Okay. So the option D is going to be our correct answer. Now the same thing they have solved as well. So you can see that, but whatever I have discussed by writing the exact thing by mentioning how we put z equal to 0 to get the surcharge at that point that much to avoid the chances of the tension crack, as the depth of the tension crack is 2c root 2c upon root k. Sorry. Okay, so next question is 6-meter high retaining wall having a smooth vertical back face, retain a layer of horizontal backfill. Top 3-meter thick layer of backfill is sand having the angle of internal friction 30 degree. Bottom 3-meter thick layer clay with a cohesion C equal to 20. Assume unit weight for both sand and clay as 18 kilonewton per meter cube. The total active earth pressure per unit length on the wall. Okay, so I will solve it by myself as well. The solution is already there on the next page, but if I solve by step, the clarity will be more better. So first of all, 6-meter high retaining wall. Okay, this is the 6-meter height, and smooth backface retain a layered horizontal backfill. Top 3-meter layer backfill is sand. Okay, so I will distribute in two sections. This is 3 meter and this is again 3 meter. So top 3 meter is backfill is sand. Phi equal to 30 degree. Phi equal to 30 degree. This you understand 30. This is phi, and if phi equal to 30 degree and it is acting, asking about active earth pressure, so k is going to be 1 upon 3, rightly said. Just I am mentioning before plotting anything. And while the, as you, I think so, you must be aware about the coefficient of active earth pressure is 1 minus sine phi upon 1 plus sine phi. When you calculate 1 minus sine 30 upon 1 plus sine 30, the value is going to be 1 by 3. While the bottom layer is 3 meter thick clay with a cohesion C equal to 20, over here the C equal to 20. So if only C equal to 20 is given, we assume phi equal to 0, and if phi equal to 0, the value of k is going to be 1, because if nothing is mentioned, the phi is 0. This thing you need to understand, because if you going to take any exam, specifically if any competitive exam, the question is mentioned, some people believe that over there in the top layer the phi is mentioned 30 degree, so they assume the phi is 30 degree for the bottom layer as well, but that's not the case. If nothing is mentioned, then means that is purely cohesive soil, the value of phi is going to be 0 over there. Assume the unit weight for the both the sand and the clay is 18 kilonewton per meter cube. So total active earth pressure per unit length. Basically, they are asking about the area when we draw the earth pressure diagram for the active earth pressure. So first of all, for the top layer, for the first layer, I am writing first. You understand first layer. So for the first layer, K gamma z, I write 1 by 3, that is K, and gamma is 18 into Z. Okay. For z equal to 0, I am writing over here for z equal to 0, k gamma z is 6z, so the value is also 0. P is going to be 0. Now for the second layer, when z equal to 3, for the first layer only, for when z equal to 3, 1 by 3 into 18, 6z, 6 3 is 6 into 3, 18. So PA is going to be 18, right? Now for the second layer, when I write k gamma z minus 2c root k is going to be 1, gamma z is in this time going to be become first of all 18 to 354, because we take that as surcharge at this point of time, plus 18z, right, minus 2c root k, so minus 40 only, because k is 1. I think so I am correct. So over here at z equal to 0, for z equal to 0, PA is going to be 54 minus 40, that is 14. So first of all we have drawn as this 18, then we come to 14, this value is 18, and this value is 14. And then again for z equal to 3, 18 3 is 54, 54 plus 54 108, 108 minus 40 is going to be 64, if I am correct. Right, 64. When you calculate this area, the value is going to be like you see 64. Okay, I think so. Somewhere I am going wrong. 54 minus 2c root k. No, incorrect. 64 plus 14. Okay, I will calculate by myself. I need a calculator. Give me a minute. Okay, so 64 plus 14 upon 2 into 3 plus 5 into 18 into. Okay, some mistake is there, I think so. But I am getting 1 by 2 into 60, 1 by 2 into 18 into 3 plus 1 by 2 into 68 plus 54. I'm getting value as 144, where somewhere I have mistaken. The value is 68. The plot is exactly correct. The 18, 14. Okay, this value is 68. What I have written? Oh, 64. Sorry, sorry, sorry. Okay, now I will calculate. Uh, when we calculate 68 plus 14 upon 2 multiplied by 3 plus 0.5 into 18 into 3. Okay, 150. Okay, when you calculate the area over here, this entire area A1 plus A2, I say, I will write again. First of all, bottom one is calculated as 1 by 2 into sum of parallel side into distance between them. So sum of parallel side is going to be 14 plus 68 into distance between them is 3 plus I'm writing with mouse, so my handwriting is not over here correct that much, but I think so understanding will be clear for everyone. 1 by 2 into 18 into 3. Okay. And this value is going to be 150. When you calculate it, you will get 150. I have calculated by myself at this point of time. I am getting this value. So I think so thing will be clear. Okay. Give me a minute. Someone has written something
Hello,
in
sir.
chat. Yes.
Sir, in first case, how Z will be 0?
Sorry.
Sir, in first case, you write Z equal to 0. How it is possible? Z equal to 3, na? Z 1, 3, Z 2 be equal to 3.
Okay, okay. Give me a minute. I will explain it again in a separate page. Give me a minute. Uh,
Okay, sir.
give me a minute. I'm explaining it right now. If you have doubt, you can ask me again. I'm writing entire thing again. See, I think take a pen. See, how we solve. No, first of all, this thing is 6 meter high, right? The top three
Sir,
meter value of pi each 30 degree. And so for phi equal to 30 degree, k equal to 1 by 3. Up to that, there will be no doubt, no?
no, sir,
You can
no doubt.
say you can say yes or no. Okay. And the value of c for the bottom layer is 20. What I have remember. Okay. and the value of phi is not mentioned over here, so we take phi as 0, because if the value of phi is not mentioned, we could not assume that the phi above is given 30, we can take 30. That is not the case. Okay, now how we write? No, when we draw, we write the equation of, value of PA. You can mute yourself. If you have doubt, you can ask, please. I will ask, if any doubt, you can say yes or no by switching on your mic. For that time, please keep the mic off, because there will be no noise over here. Okay. See, equation of PA is K multiplied by gamma into Z minus 2C root K. Right? Now, as we are right, this is our layer 1, this is our layer 2nd. Okay. Now for the layer 1, when we say layer 1, for the layer 1, as we are going to calculate this value, so we write in the term of Z only. Okay, so here value is going to be PA equal to K gamma Z. K value is 1 by 3, so this is 1 by 3. Okay, now gamma value is 18 for both the layer, so 18 multiplied by Z, right? As you see, when we calculate this, this value is going to be 68. Okay. Now over here you have doubt. Now for the layer 1, first of all, at this section, the value of Z equal to 0. At this section, whatever I have circled. You can see now, Muskan, are you there?
Sir.
Yes. Now you see that the top section, which at which I have said it, this at this section the value of Z equal to 0, because it is the topmost section. Yes or no? If you have
Yes,
doubt, you
sir.
can ask. Yes. So over here, Z equal to 0. So for the value of Z equal to 0, the value of PA is going to be 6 into 0. So I will write for the layer 1, I will write at Z equal to 0, at Z equal to 0, value of PA is 0. Tell me one thing, you are clear with this point, na? PA equal to 1 by 3 into 18, Z equal to 6Z, because cohesion is not there, so minus 2C root K is 0, because cohesion is not there, so C is 0, so this is 6Z. Up to here, there will be any doubt, you can say yes or no. The value 6Z, up to this point, you are clear?
Yes,
Hello?
sir.
Okay. You have the doubt over here, how PA equal to 0, right?
Yes, sir. I have doubt how Z equal to 0.
Okay, okay, that's what I am discussing. See, for the layer 1, if we distribute in the coordinate, for the layer 1, this is the 0. If we go to the depth, this is 0, because the top layer is 3 meter depth, and this is 3. Are you getting me? That this is the 0 meter depth. Sorry, the topmost thing is the 0 meter depth, and the bottom layer is the 3 meter depth. If you distribute in the term of Z, this is the topmost distance. We are going from the top cross section to the center of the cross section. That is our 3 meter, because the soil is distributed into two layers. Because this is the stratified soil, top layer is the sandy soil, bottom layer is the cohesive soil. Okay, so the top layer is of 3 meter distance. If we say that this section, the section from where the soil layer start is 0, the section where the sandy layer get in is at 3, and so the topmost section is said to be Z equal to 0.
Yes, sir.
Okay. And the section where the sand layer is get ended is Z equal to 3. Okay.
Sir.
Okay. And are you getting my point now?
Sir,
You have
I
come for.
understand now.
Okay. So that why when I say at Z equal to 0, the value of PA equal to 0. So when we plot this graph, we say 0, and at z equal to 3, z equal to 3, this PA is going to be 6 into 3, because when we put z equal to 3, this is going to be 6 into 3, 18, right?
Yes, sir.
Okay, and for the second layer, you have cleared, or I will explain that as well.
Sir,
I can
clear.
clear now. Otherwise, I can explain. You see, for the second layer, when we type k gamma z, when we write k gamma z, k value is 1, because because the value of phi is 0. For phi equal to 0, k is going to be 1, right?
Sir.
So, so for this layer, when k equal to 1, when we say gamma z, so the first layer, the unit weight is 18 and depth is 30. So the that weight we will consider as a surcharge for the second layer, because over here as well, the value of z is starting with 0, because we are mentioning the active earth pressure for the second layer. So we say k is equal to 1, and in the topmost weight, the layer from the top layer, that is the sandy layer, is coming to be 54, that is 18 multiplied by 3, that is 54, plus 18z minus 2c root k, the cohesion is 20, so minus 2 into 20, that is 40. Now when at z equal to 0, when we write z equal to 0 in this equation, this value is going to be 18 into 0, so 54 plus 0 minus 14, that is going to be 14. Okay, and when we going at the lowermost section of our soil strata, that is at the 6 meter, so for the second layer the value is z is going to be 3, because we have started the z equal to 0 for the second layer. You can change your notation, as I have written z for the second layer as well. So many one get confused. I can change z value to y as well. We can say 54 plus 18 y minus 40. So for the second layer, when z is going to be 3, the 18 into 3, 54, 54 4 plus 54 is going to be 108. And when I subtract 108 minus 40, this value is going to be 68. When we calculate the area of this section, the value is going to be 1 by 2 into 14 plus 68 multiplied by 3, plus, because this is the sum, and we know the area over here, the sum of parallel side into distance between them. So the sum of parallel side is the 14 plus 68, by 2 into distance between them is 3 meter. The top section is the triangle, that is 1 by 2 into 18 into 3. When we add these two area, we are going to get 150. So the option A is going to be our correct answer. I think so. Things up to here will be clear. If not clear, you can ask me again. I will explain this again. That's not the problem for me. I can take the more time on the same question. That is not the problem. I will cover the rest of the thing, because I have one extra class as well. So that's not the problem. If you still have doubt, you can ask me. Hello.
Yes, sir, clear.
Clear now? Okay.
Yes, sir.
Right. Okay, so in this is 4. We will take 5 minute break, and I will join after 5 minutes again. Uh, I am here in the call as well, but I will start the session after 5 minutes, because I will take a 5 minute break at every day, for some refreshment if needed. So I will join after 5 minutes. I will be in the meeting only, but I will start my class after 5 minutes. So this there will be 5 minute break over here. Okay. Welcome back. Okay, so we will carry forward the thing which we are discussing. Okay, so we are ended for with the problem. Now we will move to our next problem. Okay, so over here we are going to discuss some of the problems before going to our next concept, that is the seed pile in the geotechnical engineering. Okay, no problem. We have some questions to discuss before going ahead. Right. Okay. So over here you can see the question is that a vertical cut is to be made in a soil mass having the cohesion C, angle of internal friction phi, unit weight gamma, and consider K and Kp as the coefficient of active and passive earth pressure. The maximum depth of the unsupported excavation. This is the standard result. You know that the 4C by gamma root K is the maximum depth of unsupported excavation, and that is nothing but when you draw a diagram. Give me a minute, I will draw something that when we draw this section, when you plot the earth pressure diagram like this, right? So this depth multiplied by 2 times is going to be 4c by gamma root k. Basically, over here the negative earth pressure is there, over here the positive is there. It is balanced up to a certain depth. That depth is 4c by gamma root k. So the option D is going to be our correct answer. Okay, I don't think this thing I need to discuss separately, because in the previous class we also taken, I think so, it's derivation as well. So I think so you can go across that class and you can see this as well. But this is a standard result you need to remember as well, because this is the question which is asked many a times in the GATE examination and engineering service and other state services examination as well. Okay, you can see the option D is the correct answer. So explanatory thing I am not taking over here for this question. Okay, now this is an interesting problem, and I will solve it by myself again. This question, because over here a question is stating that a soil profile at a site consists of 5 meter thick sand layer underlain by C5 soil, as shown in the figure. The water table found at 1 meter below the ground level. The entire soil mass is retained by a concrete retaining wall and is in the active state. Back of the wall is smooth and vertical. The total active pressure expressed in kilonewton per meter square at point A. Okay. So you see the point A is at the 8 meter below the ground level, and over here the unit weight above the water table is 16.5 kilonewton per meter cube, and the saturated unit weight below the ground level for the sand is 19 kilonewton per meter cube, and for the second most layer, that is C5 soil, is the 3 kilo is 18.5 kilonewton per meter cube. Okay, so we have know the standard equation. We use our standard equation only. Over here there is no surcharge. Our equation is like this. PA. I am going to write it in the form of equation, because if we write in the form of equation, the question become very easy. There is no chance of error. If we solve it directly, the chance of error will be minimal. So K into gamma z minus 2c root k. Okay. Now you see, first of all, we have to calculate at this point only. So the weight above it is act as a surcharge. So we write directly for this layer only. And as Z is going to be start from this section, as we know, not need to calculate the area. So over here our Z equal to 0. Up to about that we will take it as the surcharge. Okay. So what we do, we calculate the K for this layer as 1 minus sin 24 by 1 plus sin 24. So value of K for that is 1 minus sine 24 by 1 plus sine 24. I will take this from the solution only. So you see the value of k is 0.4217. 0.4217. Okay. So I will write directly over here 0.4217. 4217. Now, when we are going to calculate PA, we write 0.4217 multiplied by the upper weight is act as a surcharge for this case. So 16.5 into 1, 16.5 into 1, that is 16.5 itself. After that, 19 minus 9.81 into 4 plus 19 minus 9.81 into 4 plus 18.5 minus 9.81 into Z. Z is 3 over here. Okay, our bracket get closed. Minus 2 into 25, that is C, to root K, that is 0.4217. Okay, so over here when you are going to calculate this, you get the value as they have calculated k into gamma b plus 4 gamma dash plus 3 gamma dash minus 2c root k. Okay, apart from that we also add the water table, because over here the water table not eliminated. So water table up to here is 7 gamma w, so plus 7 into 9.81. When we calculate this, we got our answer. Okay, I will calculate as well. So no need to calculation, because over here the calculation is there. So what I have done, that I have applied this equation only, that is PA equal to K sigma B minus 2C root K. When I calculate sigma B is first of all for the first layer 16.5 into 1 is there. After that 4 into 19 minus 9.81, then 3 into 18.5 minus 9.81. After that, minus 2c root k, I have done minus 2 into 25 into 0.4217 root under plus 7 into gamma w, because for the water table we doesn't apply the k, because the pressure applied due to the water from both the direction is there, and so the coefficient of earth pressure is not there, because the soil mass is there. If water is present at this side as well as this side, so that get neutralized itself. This not act as the pressure which is applied on the retaining wall when it's moving away from the backfill. So for that section, the for the water table, the value of k should not be multiplied. That's why when we multiply k, we take the effective and we add the water pressure separately over there. Okay, so when we do our calculation over here, everything is mentioned. We find this only 69.65 is going to be our answer. Okay, now this come a most interesting problem, because over here there is many doubt what answer is there. So read the question once. Okay, so question state that he consider a rigid retaining wall with partially submerged cohesion-less backfill with a surcharge. Which one of the following is diagram closely represent the Rankine active earth pressure distribution against the wall? Okay, so it is saying that a surcharge is there. Okay, so if a surcharge is there and the soil is cohesionless, because we know our equation. We know our equation very easily. K A for the active case, A gamma Z for surcharge, A gamma Z plus Q minus 2C root K, PA equal to. Okay. We know this very popularly. But suppose a condition where it is the cohesionless. If the cohesion is there, the value when we plot the earth pressure diagram minus 2 0 k go that side and subplot will be like that. For surcharge also some compilation is there, that like we have taken on one problem in which they asked that how much surcharge we should apply, that there will be zero. Oh, when we plot this diagram only for the cohesive soil or as well, the diagram looks like this. So we found that 2c by 2c by gamma root k or 2c by root k, whatever we have calculated, we have solved the problem. That much surcharge if we apply 2c by root k, I think so. So that much surcharge if we apply, the value of the earth pressure at the topmost cross section will be zero. Over there the tension crack problem is something that, but the main baat यही था. Okay, so what I am saying over here is like that over here the soil is positionless, so this point get eliminated, there is no thing like that. But if the surcharge is there at z equal to 0, the value of k into q will be there. So if the value of k into q will be there, so the graph start like this. So the option number B and option number C could be our potential answer. Now we have to as option number A get eliminated, because the graph should start like this. In option number A and option number D, both the cases, the graph is not able to start when we plot the earth pressure diagram. The earth pressure diagram is plotted over here. So this option A and option D get eliminated. Now we have a doubt in option C and option B, but we don't have doubt, because when we go ahead, the gamma z is drawing linear. If z equal to 0.1, the value is going to be increased from that cross section only. So it is not possible that up to a certain, sorry, up to a certain depth this value is constant and afterwards it's get increasing. So this also get eliminated. So option number B is going to be our correct answer for the given problem, because for 0 it is q only, for 0.1 its value get increases, for 1 its value get increases, for 2 its value get increases, for 3 its value get increases. So the plot which we got for the coastal soil with a surcharge looks like this only. So this is our correct answer. So option B is our correct answer. I think so. Things will be clear in everyone. Everyone is clear with this concept. There will be no doubt over there. Those who are there, if you have any confusion regarding anything what I am discussing, you can ask. That's not the problem. At any point of time, you can ask. This is not like that. I will ask in the end. You can ask any point of time. I will try to answer whatever I am discussing, whatever the problem are going on. I will try to answer up to my ability. Okay. Okay, so that thing only they have drawn, they have not discussed the thing. So that's understanding I want to give. That's why I have did this thing. Because the sometime method of elimination work, because some people get confused in option B and C as well, because they assume what they assume I don't know, but many people write the answer for this problem is C. I don't know what they think, that up to a certain depth there will be no weight of the soil. What they think, I don't know. But I have seen the many people are answering this SC and some people are also answering D. What are the thought process regarding this problem? I don't know. Okay. Now we have moved to our next problem. And basically, whatever we are reading, the basic concepts, basic understanding should be clear. Specifically when we are going for any problem, that how we are approaching, there should be a system, there should be approach. Like what I have said, always solve by writing equation in the form of k gamma z minus 2c root k. I form the equation. After that I put z equal to 0, z equal to 3, or whatever the thing which we have discussed before the going to our break. So in that fashion only I write the equation, then plot, and very rarely I am gone wrong in that approach. So you form a system, you form a things for this type of question, because there will be no hi-fi thing in this question, very basic thing. But what the question is asking is also important. Like we have solved a question in which they are asking the earth pressure in kilonewton per meter square at a specific section A. Over there, the two layer is there. The water table is at the 1 meter below the ground surface, and after that, at 4 meter depth, the soil property is phi value something, and after that, the property of C and phi is also there. So we need a better understanding regarding the same, that what the question is asking and what we have to answer. Basically, sometimes um, we answer the different thing what the question has asked. Specifically in any examination, if they are asking the earth pressure at a specific section into kilonewton per meter square, and we are going to calculate the total earth pressure, that is area, sometimes they are asking that the resultant earth pressure acting, we could also calculate that if the simple section 1 by 2 into k gamma h square, the earth pressure is acting at h by 3 from the base of the ground. So those things, what the question is asked and what we are answering, we should be aware, because in the examination, like get the numerical answer type question are there, and over there if you did some such mistakes, you know everything, but the blunder get happens, and those blunder you need not to do specifically in any competitive examination specifically. And over there the numerical answer type question are there, specifically the get question is there, and by knowing and doing the wrong thing after coming from exam, and you think that I have did everything right, but why I'm not getting the marks. So those are the things, those are the mistakes, the similar mistakes people attempt, specifically in the soil mechanics, environmental engineering, surveying. Apart from that, in transportation engineering as well, the basic mistakes people performs, and they suffer a lot of mark for that. So see, the basic concept, basic system you need to understood for the every type of problem, and you apply the same system for the all questions. If that come in the uh, different fashion, the question would be same. Okay, I am going ahead. I am deviated from what we are discussing. Okay, so question over here. It is a rigid, smooth retaining wall of height 7 meter with a vertical backface retains saturated clay as a backfill. The saturated unit weight and the undrained cohesion of the backfill are like 17.2 and 20 kilonewton per meter cube and 20 kilopascal respectively. The difference in the above lateral force on the wall in kilonewton per meter, uh, length of the wall up to 2 decimal place before and after occurrence of tension crack. Okay, so I will draw and explain the thing, and then we see the solution from the solution from the solution slide, which is in the next section. So first of all, I will explain this. See what it is asking, that there is a tensile crack get developed due to the water table over there. So you see the cohesion is there when we plot the first time, the our graph going to plot like this. But if the tension crack get developed, if the tension crack get developed, we eliminate this section. So after that, we eliminate this section and we calculate this depth as 2c by gamma root k. And afterwards, we draw this. And we have to calculate the above area, positive plus negative, and then this positive only, and then we subtract these two. So you see this negative section is there and this positive section is there somewhat. So this value is going to be this much area, so you need to subtract this area, like I say this as 1 from 2 only, you will get the answer. Okay, things will be clear when we see the next slide. I'm not going to solve it over here because the solution is already mentioned over here. You see, first of all, the earth pressure when the tension cracks are developed, and when the tension cracks are not developed is drawn over here. When you see the diagram on the right hand side, the in the first diagram, they have drawn the section when the tension crack is not there. If the tension crack is not there, the earth pressure basic k gamma z minus 2c root k they have plotted. And you see 2c root k equal to 40. So the area above and area below, because minus 2c root k is going to be developed at the topmost section, the topmost section and the section which is presented at the 2c root k equal to 40. So that much area get eliminated. When the tension crack get developed, the overall height is going to be 4.68 meter. And how we calculated height, we know. You see the diagram on the left hand side. Over there the 2c by gamma root k, that is 2.32, is calculated. If the tension crack get developed, that is get eliminated. As you see over here, the picture on the right hand side, this is, let's see, okay, this is the minus area and this is the plus area. And the area of negative and positive is same. When we add those two area, this area get subtract is equal and opposite in sense. So this is subtracted. So this much area is only what I have written over there as one. The shaded region is one. And then when the tension crack develop, this is two. When we subtract two, one from two, or maybe two from one, we get the difference. Whatever they have asked in the same fashion, maybe because they asked before and after the occurrence. So we have subtract the before, uh, we have subtracted after from before. That's why we get the value in the negative. So this is going to be our answer. So this is the basic thing. When you apply, write the basic equation, we plot this graph, and the tensor plate concept is developed in the previous class. When you want to draw, when the tensor plate get developed, the top 2c by gamma root k get eliminated, and we draw the earth pressure diagram from the depth 2c gamma root k, and that much graph is required with us. This type of problem, this is the problem asked in the GATE examination only. Over here, whatever we are discussing is the question either from engineering services or GATE examination. The state services I have not included because I don't know, there will be no aspects I have with like the previous assignments. So that's why I need to develop my own assignment problem. If you want to discuss the different problem from say these, what type of assignment problem you are getting, I don't know. If you are interested, you can share that with me. Then I will write a mail in the chat box. You can send me over there. But I could not solve those questions because as per instruction, we could not solve the assignment problem from this session. If some assignment problem from the previous session or previous to previous session will be there, we could solve in the class. But this session assignment problem we could not solve even after the completion of assignment deadline for all of you. So, but the similar problem I can solve if those assignment problem will be shared. So that's not compulsory, but if interested, you can write me in the um, you can write me in the chat box, and then I will write my email ID on which you could share. Okay, so we are moving to the next problem. The next question is stating that a 3 meter high vertical earth retaining wall retains a dry granular backfill with angle of internal friction 30 degree and a unit weight of 20 kilonewton per meter cube. If a wall is prevented from yielding no movement, the total horizontal thrust in kilonewton per meter. This is also one of the most basic problem. First of all, you have to calculate 1 by 2 k gamma h square, that is acting at h by 3 from the base. Then a horizontal thrust F must be acting at the center, that is h by 2. So you see, I saw from the solution only. I will not going to write. You see over here what we have. Okay, sorry, I think I got confused now. If the wall is prevented from aiding, no movement. Okay, sorry. The question is about the earth pressure at rest. That's the important thing about this question, because we have solved the active earth pressure question, passive earth pressure question. Over here, the value of 5 mentioned. Whenever students see the phi value in the earth pressure problem, specifically if you know this is the chapter associated with the earth pressure theory. Whenever we see say phi, 90% of time we are going to calculate the K and going to give our answer. Here also, when I have read for the first time, I also get a think that, oh, this is the active earth pressure problem. I'm going to calculate 1 by 2 K gamma H square. So K is 1 by 3 for 5 equal to 30, and I will write the answer. And if you going to do so, the option number D, I think so, is the answer we are going to get. But the something is hidden over here. Read the question carefully. Question stated that a 3-meter high vertical retaining walls retain a dry granular backfill with the angle of internal friction 30 degree and unit weight 20 kilonewton per meter cube. Up to here, nothing is mentioned. Now, if the wall is prevented from yielding, no movement. Basically, earth pressure in rest. We understood the active earth pressure coefficient of active earth pressure as 1 minus sin phi by 1 plus sin phi and vice versa for the passive earth pressure. We also understood the earth pressure constant for earth pressure in rest condition as 1 minus sin phi or mu by 1 minus mu, whatever the value we get. So here the coefficient of friction, internal friction is given, angle of internal friction sorry is given, that is 30 degree. So the value of earth pressure coefficient at rest is going to be 1 minus sin phi, that is the 1 minus sin 30. We calculate the sin 30. After that, they are asking the total horizontal thrust on the wall. So the total horizontal thrust on the wall is going to be 1 by 2 into 1 minus sin 30 multiplied by gamma into h square. H is 3, that is 3 into 3. So the total active earth pressure horizontal thrust we are going to calculate. So see, we have calculated 1 minus sin phi, that is 1 by 2, 1 minus sin 30, sin 30 value is also 0.5, 1 minus 0.5 equal to 0.5. When we are going to calculate the total horizontal thrust, that is going to be 1 by 2 into k naught into gamma h into h, that is what I have said, 1 by 2 into k naught gamma h square. So we are going to get the value of horizontal thrust which we are getting is 45 kilonewton per meter. Okay. 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 So up to here question is there. Now we are going to discuss some of the aspects of the seat piles in geotechnical engineering.
Hello, sir. Sir, I have one doubt.
Yes.
Sir, Ka value in sand 1 minus sin phi only for dry sand, saturated sand be applicable or not?
No, that is not K. That is K naught. Basically,
Yes, sir.
earth phase.
K not. Co-
Uh-huh.
active earth pressure, coefficient of active earth pressure Ka. So in dry sand 1 minus sin phi value, it is only for one dry sand या फिर saturated sand?
It is only for the dry sand, for the wet sand, and for the OCR. Some other value is also there, which is also mentioned in the standard book. But in general, when we calculate the earth pressure theory at rest condition, we consider the dry soil condition only. Because normally what happens now, that either the active or passive state get developed in one way or the other. So when we ever, specifically in the problem perspective, when we go in the real field, there are the different condition could also be there. But in general, when we calculate, we say that is the dry condition. Why five value is mentioned? Just if we discuss about the exam perspective, not in the practical field application, we say in all those cases the value of phi is mentioned, and they confuse the question in such a way that you assume that this is active state condition. The question is asking about the active state condition, but somewhere they have written hidden the word, like over here in the same problem, and they write the no movement. They have written everything very clearly, but if they write only the no movement or at rest at specific section in one go, we could miss that out, and this could be possibility that we solve this problem at the active state condition. And when you solve this question as 1 minus sin phi by 1 plus sin phi, I think so some of the option may be 30 or 270. I think so 30 is going to we will get if you calculate this question as active state condition. The option B, that is 30 answer is we are going to get. So we need to understand. And similarly, if you solve this problem for the passive perspective, the 270 will be our answer. So in exam, those things are get confused. But we use 1 minus sin pi. Over consolidation ratio concept is also there. If soil is over consolidated, 1 minus sin pi up to the power OCR or root OCR is also there for some silty soil. Some interrelation are there that I don't remember at this point of time. So I can't tell you at this point of time. But if you are interested, I will come with that in the next class. But some more interrelation are also there. If the soil is over consolidated, like OCRS mentioned in the problem, over there, if in the rest condition also we use 1 minus sin phi to the power OCR or root OCR. I don't remember at this point of time. But those interrelation are there when we are going to discuss the earth pressure interest also. Similarly, for the saturated or when the bulk unit weight we take, there must be some interrelation, but I could not recall as per my memory. So we can, if you are interested, I will come with that in the next class. Otherwise, you can see in the books, and but the value would be there. The value, different value would be there. 1 minus sin phi only is not. If the something mentioned that the over consolidated soil, OCR is also mentioned, the relation become changing. Okay, okay,
Okay, sir.
Muskan.
Okay, sir.
Okay. Okay. Any other doubt?
No, sir, no doubt.
Okay. So now we will discuss very small aspects of the seat pile wall before ending the today's session, because it is hardly 15 minutes left for the day. So I will discuss in very brief the seat pile wall, and then we will carry this discussion forward in the next class. Okay. So let me see how much I have. Okay. Let's see up to which we could keep our discussion. Okay. No problem. Let's start. So we are discussing the seed pile in the geotechnical engineering. Over here, first of all, what we have read, we have understood the shear strength determination for the difference file. Yes, in the starting class only, we have understood this thing, shear strength determination. Afterwards, we have discussed the direct shear test, vane shear test, and tri-axial test in the next two classes. We have discussed in detail the direct shear test and the tri-axial test. Vane shear test also we have discussed and solved some problem associated with the same. As we moved ahead, we discussed the different parameter like the cohesion, angle of internal friction, the value of maximum principal stress, minimum principal stress. Apart from that, when we have discussed the triaxial test, we understood the value of sigma 1, sigma 3, and how we are able to calculate. We understood the different stages like the confining stages and the diabatic stages. We understood how to calculate the pore water pressure while determining the triaxial test. We also come to know that in the direct shear test, what are the limitations? In a vane shear test, it is applicable for the soft type of soil. We also did the box test, that is direct shear test only. So a large box shear test is also there, and a normal shear test all of you have performed in your Bachelor of Technology in Civil Engineering coursework. So over there, when you have going to solve, when you have performed the shear test, you come across the small 6 into 6 cm box in which the soil is prepared and then hammered. So over there, some limitation is also mentioned that this is not going to perform if the soil size is high. Like if the, some boulder or covers are there in the soil, so we could not able to perform. But that's not the case. And the large box shear test apparatus is also there. Over there, the different soil property, the soil of the large size, maybe purely sandy soil may be also there. So that on that also the test could be performed, and for that the different apparatus is developed over there as well. The thing over here, the probing ring is there. Similarly, over there the apparatus are there. Nowadays the computational facility get developed. We get all the result in the computational facility as Excel sheet. After that, we plot our result to get the value of failure. We are able to plot the shear stress versus shear strain, which we are not plotting earlier. in the direct shear test specifically when whatever we have did in our undergraduate courses. So those advancements are there. Okay. So apart from that, what we have understood the importance of water. As I have said earlier, and I have said again and again from the first class only, that water is the biggest enemy of the soil. If the water table is not there, the 90% of the problem associated with soil could be eliminated. So important of the pore water pressure parameter we have understood. Apart from that, when we have performed the triaxial test, we understood the Skempton parameter as A and B as B as delta U by delta sigma 3. Similarly, A as change in the pore water pressure by changing the derivative stages, and it is associated with A bar as well as A is equal to A bar into B, and A bar equal to delta U by delta sigma 1 minus delta sigma 3. So those things we have discussed during our triaxial test. On the behavior test, we have solved some problem as well, and on the triaxial test, we have taken the many problems in the fourth or fifth lecture. In on a direct shear test, we have solved the problem associated with that. Okay. Afterwards, we have gone across the earth pressure theory. And in earth pressure theory, we come across the active passive earth pressure theory. We come across the earth pressure when at rest conditions. So those things we have gone in a very large detail. So afterwards, now we start with the seat pile wall. What is its importance? What is that? And what are the things associated with that we need to take care of? Okay. So first of all, starting with the seat pile wall, we say that the seat pile walls are the vertical barriers made for interlocking, made of interlocking steel or concrete sheets that are driven into the ground to provide support for the excavation or to prevent the soil erosion. They are commonly used in the construction and the civil engineering projects. So this is the basic definition. Like the seed piles are normally used to protect, to prevent the soil movement ahead, and maybe some construction work or some work are going on. They also act as a support to provide the excavation work or any work which is going inside, so that the people's working over there be protected as well in some places. In the tunnel construction over there, or maybe specifically some like you see during the construction of bridges, if we construct some foundations of work over there, also there the seed pile work is used to prevent the soil mass water could be kept away from that. That is the large process. And if you have seen some bridges construction over there, some seats are there. So but that is a different aspect, but those things you could see in day-to-day life as well. If you come across at any places the construction of bridge work is going on, specifically in the river plain, like inside water plain, specifically if you have gone across. Okay, so seed pile wall are typically thinner than the masonry or the reinforced concrete retaining wall, such as the cantilever retaining wall, and they can be constructed using the material such as steel. And if they are constructed with the steel, they are very easy to dismantle as well. If they need, they are provided to support the structure only. They could be dismantled and moved from one place to other once the work is goes on. But that is not only aspects we are going to discuss the sheet pile. So, as it could be made of concrete, timber, steel, but as we see when we talk about the different material which are used for the construction of the sheet pile wall, so one aspect become very important, that the different material could be used, but one we should need to understand that the different material could be used, but where what material we should amplify or implement depend on the type of work which we are doing across after the construction of the seat piles over there. Okay. So, as the steel seat piles are the most commonly used type of seat pile wall due to their strength, durability, and its versatility as well. So, those things are very simple things, and you understand. Okay, now see some of the small definition associated with the seed pile walls, as it is used in the wide variety of application, like it is used in a retaining wall. So seed pile wall can be used to retain the soil and prevent the landslides, especially in the area with steep slope or unstable soil condition. It like the second is the coffer dam. So the seed pile wall are often used to create the coffer dam, which are temporarily enclosed that allow the construction to take place below the water level. So that's what I am discussing about the coffer dams, which are constructed specifically in the water bodies, to protect the temporarily close the water to flow into, and that is a complex engineering process. So that act as a coffer dam over there. Also, the seed pile could be implemented. Apart from that, the sea walls and bulkheads. So the seed pile walls can be used to protect the shoreline from erosion and flooding. Okay, we have seen, if you have gone across the building material coursework over there also, we come across some of the concepts which we use to protect the seashore. I think so in the building material or construction management. I think so over in that coursework only you come across the some of the terms. Over there, the coffer dam term is also there. Bulkhead concept is over also there. So at those places as well, the seed piles are widely used. Now the next one is the bridge foundation. So seat pile wall can be used to support the foundation of the bridge and the other structure that are built over the water, that I have already said. Apart from that, the underground structures, the seat pile walls can be used to support the excavation of the underground structure, such as the basement or parking and garage. As you have seen that, specifically if you are from the metro cities, for taking the example of metro of Delhi, you see over there everything is below the ground level. So over there, how the construction takes place. Now the tunnels are developed in such a strength that it will not collapse in that manner. The property of soil should also be there, the important factor. But during the construction, the support need to be provided, because if the people's engineers, workers are working over there, they need to be feel protected. As you see, and, there are the metro stations. Like suppose taking the example of Delhi, if you go to Rajiv Chowk, that is below the ground level, and that is a very wide structure. So over there, how the possibility could be there that that will be developed. So during the construction, some support need to be provided. So over there also, these type of seat pile walls could be used during construction. Could be not. It must be used, because in any places if the underground work is going on. Take the example of small parking area. If you are going to construct in our houses only, over there also some support need to be provided, is to prevent the soil from falling down during the work is going ahead. Afterwards we prepare some wall, retaining wall, or anything else depending upon the soil property over there, to get prevented from such damages. Okay. Now we see the seat piles walls are constructed by driving the, over here you can see the images. So by driving the prefabricated sections into the ground, and these sections are interlocked to form a continuous wall, and depth to which the seat piles are driven depends on the soil conditions and the required load bearing capacity of the wall. That is the important factor, because if that much load it could not bear, so its implementation is of no use. So by this manner we implement that it will prevent the section aside it from moving in that section. Okay, so see how much thing are left with us. Okay, so this will be going to be our last slide for the day, and we will sum up from here only. And because over here the new thing is going to start, so I will try to keep this session up to here only. We will carry forward the things in the next session. So I will go across this slide and we'll sum up the today's session from here. Okay, so the seed pile walls offer a number of advantages over the other types of retaining walls. What are those advantages? First is the strength and durability. Seed pile walls are very strong and durable and can be withstand the high load and the harsh environment conditions. So this is the one of the aspect like it will, as you see, we have said that this could be used during the construction. Sorry, as we have said, this could be used for the construction of underground structures and many more things. So over there also the conditions are not as expected. The soil maybe stratified layer could be there. Depends where the construction is going on. So it has a high strength and the durability as well. Basically, the durability aspect also associated with the material which we use to construct the seat pile wall. Next one is the flexibility. Flexibility is the thing that the seat pile walls can be constructed in a variety of shapes and sizes, making them suitable for a wide range of applications. So it is not a thing that when we construct the seat pile wall, it could be only create a flat section. We could create a circular arc as well. So those aspects could also be carried forward with the seat pile walls. That is one of the also one of the advantage, that is flexibility to amplify in any shape whichever required for the construction practices. The third one is the speed of construction. Basically, the seat pile walls can be constructed relatively quickly compared to the other types of retaining wall. Obviously, because this is constructed at very high pace, the material is there. After that, we just amplify, apply at the places where we want to. So it is also one of the important aspects. After that, the seed pile walls can made water light, make them ideal to use in the application where the water exclusion is important. If at some places water need to be removed, over there also this could be used specifically in the construction practices, or sometime in some cross section where work is going on, water gets filled again and again. Over there, if we use apply the seed piles, so this problem could be get eliminated. Okay, so the seat pile are a versatile and effective solution for a wide range of construction in a civil engineering project. So we will discuss about these things in detail in a next class. So before going to end, I have some of the things which we have discussed today class. So the some of the output which we gathered from the today class is that we understood the earth pressure theory, we understood the Rankine theory earlier as well, but we have solved the problem associated with this one, not only Rankine theory, Bell theory as well. Active and passive earth pressure problem we have discussed in the today and previous classes. We also discussed those concepts. Now we are discussing the seed pile walls. We are left ahead of the target which we are targeting in the today class, but that's not the problem because I have one extra class as well. So whatever thing left behind I will cover because I have planned to take one extra class. This is a 12 class series, but I try to take the 13th class as well. Maybe that is a revision class, or if something left behind I will try or something covered in a very quick manner. I will try to solve cover those things on that those lectures. Okay, so some of the questions like the Rankine theory, assumption of Rankine theory, are some of the questions which you need to write in every class. At the end, I have given the some of the questions associated with that. So try to write those questions by yourself. So that will give you better understanding of the subject. And the some of the numerical problem we have solved in the class. Try to solve those similar problems from the books whatever you have, or you can refer these books as well, which is mentioned over here in the references. And some other books are also mentioned in the course tutorial, and that these books are the reference books. So you can go across those books to solve the problem associated with the today class. So that much for today. Thank you everyone for joining. We will
Sir,
meet in the next class.
hello
Yes,
sir.
yes.
Sir, when will next class?
Next class is on next Saturday from 3 to 5 only.
Sir, this Sunday will not class, na?
No. On Sunday there will be no class.
Okay, thank you so much, sir.
Okay, thank you very much for attending the session. Wish you all the best. So solve the problem as much you can so that your concept will be clear. And if any doubt remain, whatever we have discussed earlier, you can ask me. I will try to answer those things, whatever problem are there. So I will try to answer those things. Maybe not in the that class only. If I am not aware about those things, I will try to answer in the next class. But you could ask me anything, whatever we have discussed till now. I will try to answer them.
Okay, sir.
Okay.
Okay, sir, thank you.
Okay. Thank you very much. Now I am summing up the session and disconnecting the meeting. Thank you.